Welcome to Simpliphysics. In this video, you will learn fundamentals of the refraction of light. To understand refraction, let us consider this toy car. As the car moves from a smooth marble surface to a rough sand surface, its speed reduces. However, when the toy car moves diagonally across the marble surface, its direction also changes. Similarly, as a ray of light moves from air to water, its speed reduces. This is because the optical density of water is higher than the optical density of air. When this ray of light travels at an angle from air to water, its speed reduces, and its direction also changes. This change in direction of a ray of light is called refraction. Apart from being refracted, the ray of light also suffers partial reflection by the surface of water. Now let us look at some of the very interesting effects of refraction of light. A pencil dipped into a vessel filled with water appears to be bent. The depth of water always seems to be lesser than what it actually is. This is due to refraction of light. The twinkling of stars is an interesting effect of refraction. Diamonds sparkle on account of refraction of light. Refraction has got some interesting applications as well. Optical fibers use refraction. And most important of all, we are able to see this beautiful world around us on account of refraction. Now, let us understand refraction in some more detail. The ray that travels from air to water is called the incident ray. A line perpendicular to the surface of water at the point of incidence is called the normal. Upon entering water, the ray of light bends towards the normal. This path taken by the ray of light in water is called the refracted ray. In the absence of refraction, the incident ray would have traveled straight into water. This is the projected incident ray. The angle I, that is formed between the incident ray and the normal, is called the angle of incidence. The angle R, that is formed between the refracted ray and the normal, is called the angle of refraction. And the angle delta, that is formed between the refracted ray and the projected incident ray, is called the angle of deviation. In this scenario, the sum of angles delta and r is vertically opposite to the angle I, and hence, the relationship between I, r and delta is I is equal to r plus delta. On the other hand, a ray of light traveling from water to air bends away from the normal. And in this scenario, I is equal to r minus delta. We will now investigate what happens to the properties of light as light travels from one medium to another. First, when a ray of light travels from one medium to another, its color does not change. The color of light is a perception of its frequency, and this means that the frequency of light also does not change when a ray of light is refracted. When a ray of light moves from one medium to another, its velocity changes. According to the wave equation, the velocity of a wave is a product of its frequency and wavelength. However, when a ray is refracted, the frequency of the wave remains constant. Consequently, the velocity of the wave is directly proportional to its wavelength. Refraction is caused due to the change in the velocity of light as it moves from one medium to another. This means that when a ray of light is refracted, the wavelength of light also changes proportionately in response to the change in velocity. And now, the summary of this video. 1. The bending of a ray of light, as it moves from one medium to another, is called refraction. 2. Refraction is caused because the speed of light changes when it moves from one medium to another. 3. When a ray of light travels from a rarer to a denser medium, it bends towards the normal. 4. When a ray of light travels from a denser to a rarer medium, it bends away from the normal. 5. During refraction, the wavelength of light changes proportionately with the change in speed of light. However, the color of light and its frequency do not change. That's all about refraction fundamentals. In the next video, you will learn about the laws of refraction.